For decades, Pluto existed in the public imagination as a forgotten object at the edge of the solar system. Once labeled the ninth planet, it lost that status in 2006 when astronomers officially reclassified it as a dwarf planet. To many people, the decision made Pluto seem less important, like a frozen leftover drifting in permanent darkness beyond Neptune. It became associated with isolation, coldness, and insignificance. But science has a way of overturning assumptions, especially when exploration replaces speculation. Everything changed when NASA's New Horizons spacecraft completed its historic flyby in 2015 after traveling billions of kilometers through space. What scientists discovered was far more extraordinary than anyone expected. Instead of finding a lifeless and heavily cratered world, they encountered a landscape filled with surprising diversity, enormous geological formations, and signs of ongoing activity. Pluto no longer looked like a dead relic from the early solar system. It looked alive in a geological sense, constantly evolving despite its extreme environment. One of the most remarkable regions on Pluto is the giant heart-shaped area known as Sputnik Planitia. At first sight, it appears to be a smooth frozen plain stretching across vast distances. But beneath that calm appearance, the surface is actually moving. The basin is made largely of nitrogen ice mixed with methane and carbon monoxide, substances that behave differently in Pluto's intense cold. Over incredibly long periods of time, this icy material slowly circulates like a thick fluid. Sections rise upward while others sink below the surface, continuously reshaping the terrain and erasing impact craters. This process keeps parts of Pluto looking unexpectedly young. Scientists believe Sputnik Planitia may also have affected Pluto's orientation in space. The basin is so large and heavy that it could have caused the dwarf planet to gradually shift its position through a process called true polar wander. In simple terms, Pluto may have physically reoriented itself because of the forces created by this enormous frozen region. That idea transformed how researchers think about small worlds in the outer solar system. A body once assumed to be simple and inactive suddenly appeared capable of large-scale internal change. Beneath Pluto's icy crust lies an even more intriguing possibility. Many planetary scientists suspect that deep below the frozen surface there may be a hidden ocean of liquid water. Although Pluto is extremely far from the Sun, heat produced by radioactive elements inside its rocky core may still provide enough energy to prevent the entire interior from freezing solid. If this underground ocean truly exists, Pluto would belong to a category known as ocean worlds, joining places like Europa and Enceladus where liquid water may survive beneath thick layers of ice. The idea of an ocean inside Pluto carries major implications. On Earth, liquid water is closely connected to life. Even the harshest environments on our planet, including deep ocean trenches and ice-covered regions near the poles, support living organisms. This does not prove that life exists on Pluto, but it expands the range of environments scientists consider potentially habitable. It suggests that conditions suitable for biology might survive in hidden oceans far from the warmth of stars. Pluto's surface also shows evidence of powerful forces shaping the crust. Massive cracks, ridges, and fractured regions spread across the landscape, indicating that the outer shell has stretched and shifted over time. These formations suggest that Pluto's interior may still be active beneath the frozen exterior. Even in temperatures colder than almost anywhere else in the solar system, the dwarf planet continues to evolve slowly through geological processes. Its relationship with its largest moon, Charon, adds another layer of complexity. Unlike most planets and moons, Pluto and Charon orbit around a shared center of gravity located between them rather than inside Pluto itself. This unusual arrangement effectively makes them a binary system. Some researchers believe gravitational interactions between the two worlds may generate additional internal heat, helping maintain Pluto's suspected underground ocean. their connection is not simply orbital. It may directly influence Pluto's internal structure and Pluto's atmosphere is equally unusual. Instead of remaining stable year-round like Earth's atmosphere, Pluto's thin layer of gases changes dramatically during its orbit around the Sun. When the dwarf planet moves closer to the Sun, surface ice begins to vaporize, creating a temporary atmosphere made mostly of nitrogen. As Pluto travels farther away and temperatures drop, those gases freeze again and settle back onto the surface. It is an atmosphere that appears and disappears in cycles over time. Within that atmosphere, sunlight triggers chemical reactions that create complex organic molecules known as tholins. These compounds eventually settle onto Pluto's surface and contribute to its reddish coloration. Tholins are especially interesting because they are linked to the kinds of chemistry believed to play a role in the origins of life. Even in the freezing darkness of the outer solar system, complex organic chemistry continues to occur. New Horizons also revealed something no one expected to see on such a distant world: multiple layers of bluish atmospheric haze extending high above Pluto's surface. These delicate haze layers scatter sunlight and create an almost glowing appearance in the dim outer reaches of the solar system. Their existence showed that Pluto's atmosphere is far more dynamic and structured than scientists had predicted before the mission. Beyond Pluto lies the Kuiper Belt, a massive region filled with icy objects left over from the formation of the solar system. For many years, these distant bodies were assumed to be frozen and inactive. Pluto changed that perspective entirely. If one world in the Kuiper Belt can possess geological activity, possible internal oceans, and atmospheric cycles, then many other distant objects may also be more complex than expected. The outer solar system may contain far more active worlds than scientists once imagined. Some researchers even suspect that Pluto could contain cryovolcanoes. Unlike volcanoes on Earth that erupt molten rock, cryovolcanoes release slushy mixtures of water, ammonia, or exotic ices. Such eruptions would represent a completely different style of volcanism shaped by extreme cold instead of intense heat. Evidence for these formations remains under investigation, but if confirmed, they would further demonstrate that Pluto is still internally active today. One of the biggest mysteries surrounding Pluto is how it maintains this level of activity despite its immense distance from the Sun. Scientists believe the answer likely involves several combined factors, including radioactive heating within the core, leftover energy from Pluto's formation, and gravitational interactions with Charon. However, many details remain uncertain, and that uncertainty continues to drive new research and exploration. Perhaps Pluto's greatest importance is not tied to a single discovery, but to the larger lesson it represents. It showed scientists that distance does not necessarily mean simplicity. A world can be tiny, frozen, and far from the Sun while still possessing extraordinary complexity beneath its surface. Pluto forced researchers to rethink assumptions about planetary evolution, geology, and the environments where life-supporting conditions might exist. What was once dismissed as an insignificant object at the edge of the solar system has become one of the most fascinating worlds ever explored. Pluto revealed that even the coldest and darkest regions of space can contain active landscapes, hidden oceans, evolving atmospheres, and complex chemistry. Its discovery reshaped our understanding of the outer solar system and reminded humanity that the universe is often far stranger than expected. In many ways, Pluto represents a shift in perspective. It taught us that exploration does not simply confirm what we already believe. Sometimes it completely changes the story. The farther humanity looks into space, the more we realize that the cosmos is filled with worlds capable of surprising us. And Pluto, once considered forgotten and unimportant, became one of the strongest reminders that the greatest discoveries often come from the places we least expect.